Okay, so we are going to go over talk about functions. Functions, and it is important to note that these functions will be meeting. We take the we'll be meeting things like we'll be reading them as like this. So this means this is a function. This is f of x. That's how we read that. Then you are going to have functions like this, g of x, and you're also going to have functions like this, h of what? H of x. So now, what things are you supposed to know? So now, questions, they won't ask you what a function is. They won't ask you, define a function. But there are some times of there's some types of questions that you're going to be asked in the first part of functions, and you also have to understand to say um, the first thing that you're going to be asked on is for example, you're given a function. Example, we say they'll say given a function f of x is equals to 4x plus 1. They'll say find, they'll say the first one, maybe they'll say f of 2. Then maybe the second one, they'll say find f of 3. So the first part is just so like for example, the first one where we're having f of 2, that just means where we're having x, we're going to substitute 2 in this function, this function. So that's the first part. Those are the types of questions you're going to find. Sometimes they could just add even a negative. Maybe they can even say negative half, like that. F of negative half. So this is the first type of questions that we are going to meet. So now, how are we going to solve that? So it's a solution. So it's just basically replacing in this original what functions. For example, the first one f of 2. So in this function, where we have x, we substitute with what? With 2. So we're going to have, so we say first write the original function f of x is equals to 4x plus 1. Then f of 2 is going to be 4. So where we have x, we put 2, then plus 1. So now f of 2 is 4 times 2 is going to be 8 plus 1. So f of 2 is just 8 plus 1, which is 9. So this is the first part. So all these here, you're going to be just substituting in the original, no matter how the function is. So long you have f of 3, f of 2, just where there's x, you substitute. For example, the first one we substituted 2. So the second one, where we have f of 3, that means in this original function, where we have x, we substitute with 3. So as simple as that. So say 2. So f of 3 is going to be equal to 4, where we have x, we're saying we put 3, then plus 1. So we have 4 times 3, which is 12, plus 1, which is going to be 13, like that. Then the third one, where we have f of half, same thing, just substituting. That's the first part. So we're going to have 4, where we have x, we put half plus 1. So we're going to have negative 2 plus 1. So that's going to be 2, 2 there, 1, 2 there, 2. So if I say 2 times negative 1, that's negative 2. Then add 1, that's going to be negative 1. That's on the first part. As easy as this. As easy as that. Okay. So now, the second part, maybe where we need a bit of thinking, though it's also easy, is when we come to deal with um, inverse functions. Inverse functions. So how are inverse functions? How do they look like? So you're going to have, maybe they put like that. So f inverse of x, this requires you to find the inverse. Now there are some steps that we ought to follow when we're dealing with inverse functions. So step one, you let the function f of x equal to y. That's the first one. Then step two, you make x the subject of the formula. Then step three is here you say now substitute x for y. That then you're done. So now here I think letting f of x to y is not an issue. Making x the subject of the formula, that's why I have to explain how you make something the subject of the formula, but this is just grade 9 work. Then now substituting x for y is just easy. The only step here that needs me that I need to take some time is on the second step where we are making x the subject of the formula. So I'll just take examples here. So for example, they say we have a function. Have this function. Let's say maybe y is equals to 4x plus 1. We make x the subject of the formula. So what happens here is we're going to apply some rules of this is just basic algebra. So you can also rewrite this as 4x plus 1 is equals to y. So we want to remain with x on one side. So meaning this positive 1 goes the other side, and since it's positive, crossing the equal sign is going to be negative. So we have 4x is equals to y minus 1. So to remain with x there, we have to divide by 4 and divide by 4. So our x is going to be y minus 1 over 4. This is how you make x the subject of the formula. Sometimes you're going to have 1 over x is equals to y plus 1. How do you make x the subject of the formula there? So since you're having a denominator, you have to multiply x throughout to do away with this denominator. So you have times x. So let me just do it from here. So x times 1 over x is equals to x times y plus 1 times x, like that. So now here remain with 1. There you have xy. Here you have what? X. So rewriting this, you can write it as xy plus x is equals to 1. Now here you have x being common there, so there's nothing that you're going to take the other side. So what you do here is that you factorize what is common. It is x. There what remains, we're going to have y. So when we say x times y, it takes us back to xy. Here move the x, we're going to have 1, so that x times that's 1. And then we just divide by y plus 1 that is in the brackets there, y plus 1. Then x is equals to cancel 1 over y plus 1. So these are the basics on how we make x the subject of the formula. Let's take other examples. Okay, so we can have, maybe we say 2x plus y is equals to 2. How do we make so we have that 2x plus y is equals to 2. How do we make it the subject of the formula? How do you make x? So the y goes the other side. So I have 2x is equals to 2 minus y. Since it's positive, it becomes negative there. We divide by 2, divide by 2. Then x is equals to 2 minus y over 2. You made x the subject of the formula. I think these basics are enough. So now let's take examples. So it's an example on how to deal with inverse functions. So we'll say given a function f of x is equals to let's say 4x plus 2. So they say find f inverse of x. find f inverse of x. So the first step is, so we say step one, we let f of the function f of x equals to y. That means this part we substitute it with what? Y. So it's going to turn to y is equals to 4x plus 2. Then step 2, we say make x the subject. So we take this, so I have y is equals to 4x plus 2. How do we make it a subject? We can write this as 4x plus 2 is equals to y. So that is positive 2, going the other side is going to be negative 2. So we have 4x is equals to y minus 2. So how do we remain with x on one side alone here? We divide by 4, divide by 4. So x is equals to y minus 2 over 4. Okay, so step 3 is now substitute x for y. So here you now introduce this. Now you therefore, after doing that, having this, then making x a subject of the formula, you have that. Now you introduce f inverse of x is equals to, so like the way we're substituting there, seeing that here in the brackets we have x, we don't expect to have any other letter apart from what? X here. So that means here where we have y, we'll put x, then continue like that over 4. Then you found your inverse of x like that. So you set first let f of x to y, then you have this, then you do that, you make x subject to the formula, then you have that. Let's take another example, another simple example. So 2, we have the function h of x is equals to 4 over x plus 1. Now we are told to find h inverse of x. Same steps. So you let, here I'm not going to show them as I was showing them in the previous example where I mentioned them. So this is step 1, step 2, step 3. No, I'll just tell you to say, oh, step 1 you let that equals to that. So we say let h of x equals to y. So that means this part will be substituted with what? Y. So y is equals to 4 over x plus 1. Now, after doing that, we make x the subject of the what? Formula. I remember I gave you a situation where we have a denominator like that. So let's deal with the denominator. How do we deal with the denominator? We multiply it throughout. So we're going to have x times y is equals to here x times 4 over x plus 1 times x. So x times y is going to be x. It's going to be x y is equals to x times that. So this cancel out. Our main aim of multiplying through, I want to, because we don't have any denominator, because working with your denominator can be tedious at some point. So we cancel there. We have 4, then plus 1 times x, that's going to be x. So we now collect like terms. So the x joins with the x there, so we're going to have xy. This is positive, crossing the equal sign becomes negative. X is equals to 4. Now at this point you have two uh, x there like that. There's no what's this variable that you're going to take there, because if you take x there again, it's just going to go back to this. So when you have this situation like that where you have terms of x being common on one side, you factorize. So you factorize x there. Here we're going to remain with y, then there you are going to have 1, so we come and say x times y, we're going to have xy, then x times negative 1 is going to be negative x, then you equate it to 4. Now how do we remain with x on one side? We divide by what is in the brackets, then x is equals to 4 over y minus 1. Now the last step is you just say um, f, oh sorry, it's h inverse of x is going to be, since we are having x in the brackets there, so that means here where we have y, after making x the subject of the formula, we have to substitute x for y. So that means here where we have y, we put x, so we're going to write it the way it is. So it'll be 4 over here where we're having here where we are having y, we substitute x as the last step. So we're going to have x minus 1. Then you are done. As easy as this. So this is what we do. This is what we do. Do like that. So as easy as this. So this is paper one week. This is paper one week. Just as easy as this. Okay. So that, okay, then inverse functions. Then we just remain with one component, which is composite functions.